Welcome to our eye-opening discussion on the complex world of renewable energy. While renewable energy is often touted as the ultimate solution to combat climate change, the truth unquestionably goes deeper. In this video titled, "Why Renewable Energy is Not the Ultimate Solution to Climate Change," we will dissect the unseen side effects of renewable energy, exploring the various ways it could potentially contribute to environmental concerns. Get ready to confront the less talked about challenges renewable energy faces, from wildlife impact to carbon emissions in manufacturing, and much more. Let's dive in and uncover the nuanced role that renewable energy actually plays in our battle against climate change. 1. Wildlife impacts. Wind turbines, often hailed as a pillar of sustainable energy, come with their share of hidden costs. One primary concern is the threat they pose to wildlife. Birds and bats, which traverse the skies in large numbers, can fall victim to turbine blades. The rapid movement of the blades can be nearly invisible to these creatures, resulting in thousands of bird and bat casualties annually. This is especially problematic in poorly sited locations, where the placement of turbines coincides with avian migration paths. Even though efforts are being made to mitigate these impacts with better planning and technology, the danger remains significant. Wildlife conservationists emphasize the need for careful site evaluation before erecting turbines. It's a balancing act between harnessing wind energy and preserving wildlife, reminding us of the broader challenges of environmental conservation. 2. Noise pollution. Another less discussed aspect of wind energy is the noise pollution. While wind turbines might appear serene from a distance, they produce low-frequency noise and vibrations. This continual humming can disturb nearby residents and wildlife. For some humans, this disturbance can lead to health issues such as sleep disruptions, which in turn affect daily life and productivity. Communities living close to turbines have voiced concerns about this, even though the official stance often downplays these issues. Wildlife, too, senses these vibrations, which can influence their natural behavioral patterns, ultimately impacting local ecosystems. While technology continues to advance to reduce this noise, it hasn't been eradicated entirely. Therefore, this noise pollution becomes a critical consideration in planning wind farms, not only for human residents but also for the animal inhabitants. 3. Land use. The installation of wind farms demands a substantial chunk of land, and this can present significant challenges. These large-scale projects can disrupt local ecosystems and change land use patterns. For an area dedicated to agriculture, the introduction of turbines can mean less land available for farming, affecting crop yields and local economies dependent on agriculture. Additionally, natural habitats might be altered or disturbed, impacting the flora and fauna unique to the region. This can, at times, lead to conflicts between energy developers and local communities who rely on the land for sustenance. The debate continues on how to best balance the need for renewable energy and the preservation of agricultural and natural land. Hence, land use becomes another hidden cost of wind power that requires thoughtful management and responsible development. 4. Material and resource extraction. The creation of wind turbines involves a range of materials like steel, concrete, and rare earth metals. This necessitates extensive mining and processing operations, which can cause environmental degradation. Large-scale mining operations impact landscapes, often leaving behind a trail of destruction. These activities also contribute to high carbon emissions, contradicting the low emission profile of wind energy during operation. Communities living near mining operations often report disruptions, with concerns about decreased air and water quality. As demand for wind energy grows, so does the need for these materials, amplifying environmental concerns. Careful consideration of supply chain impacts is essential when assessing the overall environmental footprint of wind energy. These factors, though not often highlighted, play a crucial role in the true cost equation of wind power. 5. Turbine blade waste. Wind turbine blades pose a unique challenge when it comes to waste management. These blades, made of durable composite materials, can resist natural decay, making them difficult to recycle. As more turbines reach the end of their 20-30-year lifespan, the world faces a growing pile of non-recyclable waste. This issue has sparked global attention as landfill sites begin to swell with decommissioned blades. Scientists and engineers are striving for innovative solutions to recycle or repurpose these materials, but the journey is still in its infancy. The wind energy sector must address this looming waste challenge if it is to maintain its environmentally friendly image. Therefore, turbine blade waste remains an often overlooked yet significant cost of wind energy sustainability. 6. Intermittency and grid challenges. Wind energy, by its nature, is dependent on the whims of nature. Its intermittency can pose significant challenges when integrating wind power into existing power grids. Since winds don't blow consistently, backup systems or energy storage solutions are necessary to ensure a steady power supply. These additional requirements can increase the complexity and cost of wind energy systems. Power outages and grid instability can be problematic in areas overly reliant on wind energy without adequate backup. While technology solutions like large-scale batteries are being developed, they are still expensive and not widely implemented. Intermittency effectively underscores the fact that wind energy is not a standalone solution but must be part of a broader energy strategy. 7. Carbon emissions in manufacturing. While wind turbines generate clean energy during their operation, the manufacturing, transportation, and installation processes contribute to carbon emissions. These embodied emissions result from producing the raw materials, constructing the components, and transporting them to their final destinations. This initial carbon footprint can take years of operation to offset, even with the clean energy produced by the turbines. This reality means that the environmental benefits of wind energy don't start immediately but accrue over time. Advocates argue that these emissions are a temporary hurdle, but they are an important consideration in the broader environmental equation of wind energy. It's critical to make these processes more efficient in order to reduce the carbon footprint from start to finish. 8. Impact on local climate. Wind farms can influence local microclimates by redistributing heat and moisture near the Earth's surface. This change can introduce unintended effects on local ecosystems and weather patterns. Studies have shown that large turbines can bring slightly warmer temperatures at night over certain regions. This can have implications for agriculture and wildlife dependent on specific climatic conditions. While the overall impact is minimal on a global scale, it's a localized cost that requires monitoring and management. Communities and environmental planners must stay vigilant about potential changes that could affect local livelihoods and biodiversity. Consequently, these climate implications add another layer of complexity to the perceived simplicity of wind energy solutions.